One of the last things that needs to be discussed with respect to integration by substitution is how we handle bounds of integration. So for instance, if we have a problem that has bounds, like the integral from 0 to pi over 2, of, say, for instance, the sine of 2x dx, how do we deal with those bounds when we perform a u substitution? So hopefully you've seen enough of these problems to recognize that we do need to do a u substitution here. We do not know what the antiderivative of sine 2x is. We know what the antiderivative of sine x is, but not sine 2x. So we'll begin this problem, as we've done many others, by stating that u is going to be 2x. The following step is to find the differential. That means du is 2 dx. My step after that is to solve for dx, so we end up with du over 2 equals dx. And now when I bring these things back to the problem, you'll note I'm not going to write bounds on this integral. I'm going to write that this is the sine of u times du over 2. And the way that I really want you to think about this is that this original problem was all in terms of x. And when I say all in terms of x, I mean even these bounds were x values. It was saying, that we want to do this integral from an x value of 0 up to an x value of pi over 2. So down below, where I've changed this problem into a u problem, it doesn't make sense anymore for me to have x bounds. In fact, if anything, I need to have u bounds for these things. So what I need to do is I effectively need to determine what the new bounds for the problem are. And the way that we do that is it's actually kind of like what we did in the last video. The last video was called using multiple substitutions. And it sort of had to do with the fact that we used this substitution more than once. And I'm going to use it here as well. If my original bound was x equals 0, let's use the relationship u equals 2x to find out what the new lower bound is going to be. Well, if I plug in 0 there, I'll get u equals 2 times 0, which is 0. Great, so the lower bound is 0. As far as the upper bound, well, my old bound was x equals pi over 2. So if I plug that in to u equals 2x, I'll find that u is 2 times pi over 2, which is pi. Great, so my new upper bound is pi. And now I've transformed this integral from being completely in terms of x, including x-valued bounds. Accidentally hit the stop button there. I've transformed it from being entirely in terms of x to a new integral that's entirely in terms of u, including u bounds, where I've said that the lower bound is u equals 0 and the upper bound is u equals pi. From this point on, the problem has been transformed, and we can just work through the whole thing. So I'm going to take this 2 that's on the bottom here, I'll pull that out front. So that means I'm going to end up with 1/2 the integral from 0 to pi of sine u du. We recall that the antiderivative of sine u is negative cosine u. So I now have 1/2 of negative cosine u being evaluated from 0 to pi. So I'm going to have, I suppose I could say negative 1/2 cosine pi minus a negative 1/2 cosine 0. Note I'm just plugging in pi first and then 0 second. Cosine of pi is negative 1, so this ends up being 1/2 plus, and the cosine of 0 is 1, so this is another 1/2. So my final answer is 1. And that's the end of the problem. We're done. We did the substitution. So recapping briefly, the short of it is simply when you do a u substitution, make sure that you plug your old bounds into the u substitution in order to find out what the new u bounds are, and you can just use those to plug into the problem and use the fundamental theorem of calculus, which is the fancy way of saying, plug in the top number minus plug in the bottom number. Do that and you'll get the answer. Not a big deal. I do want to look through, I do want to talk about one other style of problem, which is sort of a multiple choice problem, and so we'll look at that next. So, multiple choice question from a past exam that we're going to look at here. In some sense, I wish that I could come up with a new one, but I'm short on time at the moment, so I'm going to pull this question from my 2011 exam. So let me bring this up. So the question simply says, which of the following integrals is equivalent to this given integral, the integral from 2 to 4 of x times the square root of x squared minus 3 dx. And notice that all of the answers are basically other integrals that are all in terms of u. So effectively what the problem is saying is it's saying, hey, transform this integral into another one, and then don't finish doing the integral, just tell me how the change of the bounds worked. So if you're feeling bold, work this one out on your own and check the answer. Pause it, and I'll work through it here. So if we have the integral from 2 to 4 of x times the square root of x squared minus 3 dx, that wasn't a very good squared minus 3 dx, it seems pretty clear to me that your choice of u is going to be x squared minus 3. Remember from the last video, I tried to give you guys sort of two criterion. One, we want to choose something whose derivative shows up in the problem. Well, the derivative of this is 2x, and that feels like the x that's out front. Second, this thing, x squared minus 3, is being plugged into the square root function, which just sort of, you've got two things going for you. It's probably going to be a good choice. The next step, we calculate du, the differential. The derivative of this thing is 2x, and we write our dx. Then we solve for dx, getting du over 2x equals dx. So now I'll take all this information, I'll plug it back into the problem. This is the integral of x times the square root of u times du over 2x. Here we get that awesome sense of confirmation that the x's will eliminate one another. And now this integrand is entirely in terms of u. The only thing I need are the lower and upper bounds that are now in terms of u. So remember how we did this last time. We said, well, the original lower bound was x equals 2. The original upper bound was x equals 4. Let's transform those using this substitution. U should be equal to 2 squared minus 3, which means the u value will be 1. So my lower bound, which was previously 2, is now 1. My upper bound of x is 4. Let's see, we'll have u equals 4 squared minus 3. 16 minus 3 gives me 13. And so my upper bound here is 13. So now I've got bounds, I've got the problem transformed into u. All I really need to do now is finish the thing out. I'll bring this 2 out to the front, end up getting 1/2 the integral from 1 to 13 of the square root of u du. And at this point, like, I've solved the problem. It's clear that b is the integral that's equivalent to the one that was originally given. And if this was the multiple choice question, you would be done with the problem. While I'm here, I feel like I might as well finish out the problem just to sort of give one last look at this. If this were a free response question, how would we finish the problem? Well, if this were free response, your next step here would be to actually take that antiderivative. Since that's u to the 1/2 power, I'll make it u to the 3/2 power times the reciprocal, which is 2/3. And this entire thing will be evaluated from 1 up to 13. So let's see, this would be 1/3 of u to the 3/2. Again, I'm just simplifying the stuff in the front before I actually do this. Then I just plug these values in. I mean, I get 1/3 of 13 to the 3/2 power minus 1/3 of 1 to the 3/2 power, which is just kind of silly. 1 to the 3/2 power is really just 1. So I suppose I'd have 1/3 the square root of 13 cubed minus 1/3. And if I was going for dramatic effect, I would probably pull out the 1/3 and leave it as the square root of 13 cubed minus 1. And that looks good to me. Again, if this were a free response question, or if the problem had been, solve the antiderivative, find the area, find the value of the definite integral, you would get this. But I did want to point out that as a multiple choice question, this is a completely valid question, where you're simply asked, can you transform the integral? Can you transform bounds? Can you write it as a complete integral in terms of u? That's the end of this video. That's really the end of the lessons that you need for this. The problems in the homework are just sort of a collection of questions about the things we've done for the past few days. So I definitely recommend you get started on that. And other than that, I will see you in class tomorrow.